The landing gear is a primary aircraft system that supports the aircraft during taxiing, takeoff, landing, and ground handling. It absorbs landing impact loads, provides braking and steering capability, and ensures safe ground operations. Structurally, the landing gear must withstand very high vertical, longitudinal, and lateral loads and safely transmit them into the aircraft structure. Primary components of landing gears. Primary components of the landing gear are the main load-carrying members that support the aircraft weight and absorb impact loads during landing, takeoff, taxiing, and braking. These components are critical to structural safety, and their failure can lead to collapse of the aircraft on the ground. They are designed to withstand very high vertical, longitudinal, and lateral loads, and are subject to strict strength and fatigue requirements. The shock absorber, commonly known as the oleo strut, is the main energy-absorbing component of the landing gear. It dissipates landing impact energy using a combination of compressed gas and hydraulic fluid, thereby reducing the loads transmitted to the airframe. The shock absorber plays a critical role in protecting the aircraft structure during landing and taxiing. The axle is the structural member on which the wheels and brakes are mounted. It transfers loads from the wheels into the shock absorber and landing gear strut. The axle is designed to withstand bending and shear loads generated during landing and braking. Wheels support the aircraft weight while on the ground and allow smooth rolling during taxi, takeoff, and landing. They are designed to withstand high loads and rotational speeds and provide mounting locations for tires and brake assemblies. Tires provide cushioning between the runway surface and the wheels and ensure adequate traction during braking and steering. Aircraft tires are designed to operate at high pressures and withstand extreme loads, temperatures, and landing speeds. Brakes are used to decelerate and stop the aircraft during landing and rejected takeoff conditions. Modern aircraft use multi-disc hydraulic or carbon brakes capable of absorbing large amounts of kinetic energy. Braking systems often include anti-skid protection to prevent wheel lockup. Main structural struts form the backbone of the landing gear assembly. They support the aircraft weight and transmit vertical, longitudinal, and lateral loads from the landing gear into the airframe. These struts are designed for high strength, fatigue resistance, and durability. Secondary components of landing gear. Secondary components of the landing gear support operation, control, and functionality, but do not carry the main landing impact loads. Failure of these components does not immediately cause structural collapse, although it may affect ground handling or operational safety. These components are designed primarily for movement control, alignment, and system integration. Torque links, also called scissor links, connect the upper and lower parts of the shock strut. They prevent relative rotation between strut sections, maintain wheel alignment, and transmit braking and steering loads. The retraction and extension mechanism allows the landing gear to be deployed for landing and retracted after takeoff. It typically consists of hydraulic actuators, linkages, and locking devices that ensure smooth and reliable gear operation. Side braces and drag braces provide lateral and longitudinal stability to the landing gear when it is extended. They resist loads caused by braking, acceleration, and crosswind landings and also help lock the landing gear in position. The steering system is installed mainly on the nose landing gear and enables directional control during taxiing. It is operated through hydraulic or electric actuators controlled by the pilot using rudder pedals or a steering tiller. Landing gear doors cover the landing gear bay when the gear is retracted, reducing aerodynamic drag and protecting internal components. Linkages connect the doors to the retraction system and ensure coordinated movement during gear operation. Safety locks, including uplocks and downlocks, ensure that the landing gear remains securely in the retracted or extended position. They prevent accidental gear collapse and provide redundancy for safe operation. Sensors monitor landing gear position and condition. These include weight-on-wheel switches, proximity sensors, and position indicators that provide critical information to the cockpit and aircraft systems.